Hi ma'am, I'm James Darunda.
I'm Junril Duak.
Lord Christian Grado.
I am Renz Gimere.
I am Lawrence A. Lapunog.
I am Jubin Siling Atong.
And today we will conduct an experiment about Newton's three laws of motion.
The first, Newton's law of motion. Inertia. An object at rest will stay at rest, and an object in motion will stay in motion with a constant velocity unless act by a new external force. Here is the example of first law of motion. A runner who is stopped by a physical block. The law of inertia dictates that the runner, due to his mass, will attempt to maintain his state of forward motion and constant speed, meaning the person blocking his path must supply a powerful, sudden, and externally unbalanced force to overcome the runner's inertia and compel his body to change its state of motion by decelerating. The second law of motion. Acceleration. Acceleration is the rate of change of velocity of an object with respect to time. It's a measure of how quickly an object's speed or direction is changing. Here's the example of acceleration. As you can see on the video, which clearly establishes that the bike achieving the greater acceleration, the one that will ultimately win the race, must maintain the highest possible ratio of net force generated by the engine's power thrust subtracted by opposing drag and friction forces to the motorcycle's total mass, or M, including the bike, rider, and fuel, meaning a higher powered engine and a lighter overall weight are the critical interconnected variables that determine success on the track. That's why the orange motorcycle is totally win the race.
Well, the harder you throw the ball, the harder it will hit you back. Why? That's the nature of physics.
Action and reaction. The Newton's third law of motion states that every action has an equal and opposite reaction. When one object exerts a force on another, the second object exerts an equal and opposite forces on the first. These forces occur simultaneously and are equal in magnitude but opposite in direction. The action and reaction forces act on different objects, never on the same object. This law applies universally, governing interactions between objects in the natural world, from a swimmer pushing water backward to a car accelerating forward. Newton's third law is at work, explaining the reciprocal nature of forces in our universe. Example of action and reaction. When two punches clash, Newton's third law dictates that the force exerted by the first person's fist onto the second person's fist is equal in magnitude and opposite in direction to the force the second person's fist exerts back on the first person's fist. Since these equal and opposite forces act on different objects, they do not cancel out but instead cause a rapid, painful deceleration of both fists upon contact.